A very warm welcome to each and everyone present today. My name is Vineet and we are going to have a session on Hadoop ecosystem. Without any further ado, we'll just move on to the next slide, that is the agendas for today's session. In today's session, we are going to go through the entire Hadoop ecosystem, which consists of various tools like HDFS, which is nothing but the storage unit of Hadoop, Yarn, MapReduce, the processing unit. We'll go through Apache Spark, the real-time analytical tool that runs over Hadoop. We'll go through Pig and Hive. We'll understand Hbase and where it stands in the Hadoop ecosystem. We'll understand Mahout and what is Spark mlib. We'll understand Apache Drill. We'll understand Zookeeper and why it is used. We'll understand Oozie and its importance. We'll understand Flume and Sqoop and how they are used to move data in and out of HDFS. We'll understand what is Solr and Lucene. And finally, at the end, we'll understand what is Apache Ambari. Okay, so this is the clear agenda for today's session. We'll move on to the very next slide and understand what is actually a Hadoop ecosystem. Okay, the very first thing is Hadoop ecosystem is not one tool. It's not a programming language or it's not a single framework. It is a group of tools that are there which are used together by various companies in various domains for different tasks. Okay, Hadoop alone cannot provide all the facilities or services that are required to process the big data. Okay, so like for example, Hadoop can store big data, Hadoop can process big data up to a certain limit. However, there are much more other requirements that are there. For example, we would like to create recommendation engines over big data. We would like to run clustering algorithms over big data. We would like to get the real-time insights using big data itself, because Hadoop is a batch processing framework, right? So if I want a real-time insight, I would need another tool that can run over HDFS, that can utilize and leverage HDFS, right? The basic thing that you need to understand here is one single tool like Hadoop is not going to solve all your problems. You'll have to use various other tools over Hadoop or along with Hadoop to get rid or get the solution of every problem that you have. Okay, but before that, before doing so, it is important that you know what are the different tools that are there which can work with Hadoop. And in today's session, we'll exactly do that. We'll try and find out what are the various tools that are there which can be used with Hadoop and what functions they can perform in their own domains. Okay, we'll now move on to the next slide. Okay, the very first tool that we'll understand is HDFS. Now, as you know, HDFS is nothing but Hadoop Distributed File System. It is the storage unit of Hadoop. HDFS is entirely the Hadoop cluster which is formed by data nodes. Data nodes are nothing but commodity hardwares which are cheap hardwares which can be clustered together using the Hadoop framework, and the entire file system that gets created on which you can store big data is called Hadoop Distributed File System. Using HDFS, you can store any kind of data, be it structured, be it unstructured, or be it semi-structured. Okay. Now, once you store the data in HDFS, you can view the entire data as a single unit as well. HDFS stores data across various nodes. These nodes are nothing but the data nodes, and it also maintains the log files of what data is stored at which position. So basically, HDFS has got two components. One is the name node and other is the data node. Name node is the one which manages the entire cluster, which manages the entire set of data nodes and keeps the information, keeps the metadata of the data that is stored in these data nodes. Data nodes, on the other hand, are the slave machines, the commodity hardwares which actually stores the data. So HDFS is the one which solves the primary problem of storing big data. So it's time we move on and explore the next tool in Hadoop ecosystem, which is Yarn. Now we'll explore Yarn. Now, as the name suggests, it is nothing but a resource negotiator. Okay. The main purpose of Yarn is to allocate resources to run particular tasks over the Hadoop cluster. So Yarn has basically two components. One is the resource manager and the other one is the node manager. As soon as the client submits a job, these resources are nothing but the containers in which the jobs can be executed. Okay, node manager is the one which finally executes the job within these containers and manages the entire thing on the data nodes. Okay, so the resource manager is the master daemon and the node manager is the slave daemon. Apart from that, I would like to tell you one important thing about Yarn. Yarn was introduced in Hadoop 2.0, which enabled various ecosystem tools to connect with Hadoop distributed file system and leverage big data. Okay, so we'll understand this better when we come to the MapReduce slide. Okay, so we now come to MapReduce, which is the processing unit of Hadoop. So once the data is stored on Hadoop distributed file system, the next task is to process that data. For doing so, one can use Apache MapReduce. In Hadoop 1.x, MapReduce was the only framework that can be used to process the distributed data that is present on HDFS. However, so Yarn was the next layer over HDFS, and MapReduce now connected with Yarn to allocate resources for executing the MapReduce task. Similarly, many other ecosystem tools or databases now can connect with Yarn and leverage HDFS. Okay, so it happened after Yarn. So essentially it has got two functions. One is the map and the reduce. Map function is used for filtering, grouping and sorting kind of functions, and the result of the map function is then aggregated in the reduce phase, and the entire summarized result is dumped on the HDFS itself. So this is how Hadoop MapReduce works. Now it's time we move on to the next slide, and we'll explore what is Apache Pig. Apache Pig was a tool that was developed at Yahoo. So it is nothing but a data processing tool that runs over Hadoop, or you can say that it sits on top of the Hadoop. Apache Pig has its own language that is called Pig Latin, which is nothing but a data flow language, or you can call it as an instructional language. For example, if you want to load a data, you have a command like load this data from path, and then you can dump that data or perform various functions like filter or group. Okay. So using Pig Latin, the life of the developers became very easy. They need not write the entire full MapReduce job for executing some processing over the big data. For people who cannot write a MapReduce program or were not comfortable with MapReduce, for them Pig Latin came as a blessing. Or for them, Pig came as a blessing. By using Pig, the task for them became very easy and they were able to leverage big data. It is said that approximately one line of Pig Latin is equals to 100 lines of MapReduce. So just think how much time are you saving there. Okay. You can perform all the ETL operations that you would like to execute over big data using Pig. So I hope this gives you a clear picture how Apache Pig came into picture, what is the importance of Apache Pig. We'll move on and explore the next tool in the chain, that is Apache Hive. Apache Hive is one of the most important tools that is there in the Hadoop ecosystem. Apache Hive was developed at Facebook. Now the idea behind Apache Hive was, the time when it was developed, the relational databases were flourishing. These were the databases that were used by most of the organizations, most of the companies. Nobody knew about NoSQL or a file system like Hadoop. Even Facebook had its website on MySQL. So the workforce there mostly was working on MySQL or SQL-like queries or PLSQL. So for Facebook, it was a problem because their workforce was skilled in SQL. However, for writing a MapReduce program, you had to know some other programming language. So what Facebook did is, Facebook came up with a tool that is called Hive, using which you can write SQL-like queries, that is called Hive query language, and execute the same task over the Hadoop cluster and leverage big data. Just like Pig, using Hive, you can write simple SQL-like queries, and the task that you were executing using MapReduce now can be executing using Hive without getting into the complexities of MapReduce. Okay. Even using Hive, you can connect from client applications like Java as well if you have that requirement. Okay, so Hive is one important tool that is used by a lot of people out there who do not want to get into writing the MapReduce program. So let's move on to the next tool, that is Mahout and Spark MLib. Mahout is a machine learning library written in Java. It can be used for creating recommendation engines or clusters of data, or classify your data into various groups. Okay, so all those algorithms that are there in machine learning can be implemented over big data using Mahout. Okay, so it provides you a command line interface to achieve the same task. You would have heard about an analysis that is called market basket analysis, which can be easily executed using Mahout over big data. There are various other things like recommendation engine, as I mentioned, which you would have seen in many e-commerce websites like Amazon, Flipkart, or many more. Okay, so all those things can be done using Mahout. Now we come on to Spark, which is a leading tool in the Hadoop ecosystem. MapReduce and Hadoop together can only be used for batch processing. That means you're not getting the results in real time. But out there is a requirement for real-time analytics as well, which cannot be done using Hadoop MapReduce, right? In that case, Sparks come into the picture, which can run standalone as well as it can run over the Hadoop cluster and leverage the same big data to provide you real-time insights, right? As well as Apache Spark is almost 100 times faster than Apache MapReduce. Okay, so I hope this excites you, right? So we'll move on to the next slide and explore Apache HBase. So what is Apache HBase? Apache HBase is a NoSQL database that runs over Hadoop. Apache HBase can be used for storing any kind of data that is there. Okay, it could be any structured or unstructured data, and Apache HBase has been modeled after Google Bigtable and can be utilized to store any big data that is there in Hadoop file system. With Apache HBase, you have an advantage, that is you can use HBase as a backend for a website or a web application to query in real time, which cannot be done with tools like Pig, HIVE or MapReduce or even HDFS. And hence it is a very important addition to Hadoop ecosystem. Okay, so guys, are you clear with this? You can also write a Java application and connect with HBase using the REST APIs, Thrift APIs or Avro APIs. Okay, now we'll go through another tool that is called Apache Drill. Apache Drill is again an open source application which works well with any distributed environment that is out there. It can work with any NoSQL database or a flat file system. Okay, the advantage with Apache Drill is that it can connect with various NoSQL databases or a flat file system or a simple file itself at the same time. So if you have data stored in various sources, like let's say you have a data stored in Hadoop distributed file system, you have a data stored in HBase, you have a data stored in MongoDB. Every one of them has their own syntax to execute queries on them to retrieve the same set of records. However, using Apache Drill, you can connect to all these databases at a single time, execute one query and extract the results from all the three databases and use it for your application. Okay, Apache Drill is able to do that because it follows the ANSI SQL, which enables you to write a query that can execute or that can be understood by all the three databases. So I hope you understand this particular concept. And now we'll explore Oozie. Apache Oozie is nothing but a scheduler in the Hadoop ecosystem. Now what does it mean? Let's say you have a MapReduce task that needs to be executed every hour. Now in that case, instead of manually triggering it, what you can do is you can define a workflow in Oozie and schedule your task to be executed after every 1 hour. Okay, when you see, you're doing two things. One is you're defining a workflow that could be one task or it could be a combination of tasks that are executed by various tools like MapReduce, HIVE, Pig, etc. in a sequence, as well as you're defining the frequency in which the workflow needs to be executed. Okay, so your life becomes very easy. You need not go and execute or trigger your job every time that it needs to be done. Oozie can do it for you. Along with that, Oozie Coordinator is another component that is present in Oozie, which ensures that the job or the workflow is only executed when the data is available. So at times, if the data is coming from an external source, automatically it will ensure that as soon as the data is in the system, then only the workflow or the job is executed. So it is an event-based execution that can be triggered using Oozie. Flume is again one of the most widely used tools which is used for data ingestion into HDFS. Okay, so using Flume you can ingest any kind of data. It could be structured, it could be semi-structured, into the Hadoop distributed file system and perform various processing after that. Flume gives you the capability of extracting data out of social media like Twitter, Facebook, or you can also extract data from servers where logs are getting generated on a regular interval. So Flume can be utilized to extract data from there and move into the HDFS. Okay. Similarly, there could be many other use cases like getting email messages or network traffic, etc. Okay. The next tool in the order is Sqoop. Sqoop is again used for data ingestion. However, Sqoop is used between relational database and the HDFS. So using Sqoop, you can move your data from your relational database into HDFS and vice versa. That means you can also move data out of HDFS into an RDBMS. So it mostly deals with structured data. Okay. So if you compare Flume with Sqoop, Flume is mostly used for moving data into the HDFS and deals with streaming data most of the time. However, Sqoop works with structured data and it can move data in and out of HDFS, unlike Flume. And we come to the next tool, that is Solr and Lucene. So Solr and Lucene is again an Apache project which has been developed in Java. Lucene in itself is a Java library which is for developing search engine and indexers. Okay. Apache Solr is an application that is built using Apache Lucene. So if you want to develop a search engine or you want to implement search onto your website, which works very fast using indexing, you can always use Apache Solr to do that. Okay, so this is the main purpose of Apache Solr, which is an application which is developed using Apache Lucene. So I hope you are clear with what is the use of Solr and Lucene. We come to Zookeeper. As the name suggests, the job of Zookeeper is to ensure coordination between various tools that are there in the Hadoop ecosystem. Okay, so the main purpose of Zookeeper is to ensure that each and every tool is able to communicate with each other without any interruption, so that the entire ecosystem works together in achieving a particular task. Okay, it performs synchronization, it performs configuration management, grouping and naming of all these things. Okay. It also manages all the services that are running in the Hadoop cluster. Okay. So Zookeeper is very important component of Hadoop cluster. If Zookeeper is not there, your services, your daemons, your tools will not be able to interact with each other or communicate with each other, and hence you will get a broken system if Zookeeper fails. I hope this is clear to you. Now we come on to the final tool, that is Apache Ambari in the Hadoop ecosystem that we are going to discuss today. So Apache Ambari is a cluster manager. Okay. What does a cluster manager mean? Or what does a cluster manager do? Cluster manager manages the Hadoop cluster. Okay. Using Apache Ambari, you can provision, manage and monitor the Apache Hadoop clusters. Okay. It makes very easy for you to set up a Hadoop cluster and then configure all the services that needs to run over the Hadoop cluster. It could be Apache Spark service, it could be a HIVE service, it could be any other service that you need over the cluster, and it can be done very easily using Apache Ambari. So this was basically developed by Hortonworks. A similar tool is developed by Cloudera as well, which is called Cloudera Manager. Okay. However, Cloudera Manager is not an open source tool like Apache Ambari. So Apache Ambari was developed by Hortonworks. However, it was given to Apache later on. A similar tool, which is a proprietary tool developed by Cloudera, named as Cloudera Manager, using which you can deploy the Cloudera clusters. However, it is a paid service. Okay. Using Apache Ambari, you can also monitor health and status of your Hadoop cluster. Now you know the importance of Apache Ambari and how it can be used to make your life easy. Okay. And with this, we come to the end of this session. Thank you. Have a nice day.